Right. So greetings, YouTube. Beautiful mind here. Let's turn down the music as much as we like to listen to it. Hope everyone's doing well on this weekend's been phenomenal. I've been vibing all weekend. Like just vibes have been high. It's been good moves, great weather, resolving stuff, growing. It's been fantastic. And hopefully you've been doing something equal of greater value, to you. Um, so with that being said, the intent of this presentation, we're going to continue. We're continuing with our calculus discussion. We're wrapping up chapter 3. So this is the second to last presentation of chapter 3 on applications of differentiation. And so this is section 3.7, elasticity of demand. A few objectives here. We would like to find the elasticity of a demand function. We want to find the maximum of a total revenue function and characterize demand in terms of elasticity. So what do we mean by elasticity of demand? The elasticity of demand E is given as a function of the price X by this, all right? So it's going to be X times D prime over D, negative of all of that, right? So this is just a formula. We're just going to use it for now and just take it as is. So we have this theorem 11. It says the total revenue is increasing at those X values for which the elasticity of demand is less than 1. So it says the total revenue is increasing when the elasticity at those X values where the elasticity of demand is less than 1. The total revenue is decreasing at those X values for which the elasticity of demand is greater than 1. And the total revenue is maximized at the values of X for which the elasticity of demand is equal to 1. Okay? So with that, that gives us the context of what's the purpose or the intent of elasticity of demand. So when the elasticity of demand is less than 1, the total revenue is increasing. When the elasticity of demand is greater than 1, the total revenue is decreasing. And when the elasticity of demand is equal to 1, the revenue is maximized. That's powerful stuff, right? Let's see it in action. This might be a really short lecture, so I might go ahead and close out chapter 3. We got one more section after this. We'll see how long it takes us to do this. So with this example, it says, this is on economics, elasticity of demand for video game rentals. The demand for video game rentals at Clicks Video Game is given by Q equals D of X. The demand function is 120 minus 20X, where Q is the number of video games rented per day at X dollars per rental. Part A X is to find the elasticity of demand as a function of X. Part B X is to find the elasticity when X is 2 and 5. Interpret the meaning of these values. And then find the value of X for which the elasticity equals 1. So these are just direct applications of the formula we just saw. So what I'm going to do, I'm going to attempt to pull that formula from memory. I'm going to go paper. I like to write like this. And then actually I'm going to do view. I'm going to do seamless. And I'm going to go ahead and give myself a second page. Okay. I probably should not be trying to do this formula from memory, but let me see if my memory serves me correct. The elasticity of demand, I know there was a negative. It was X times D prime. I don't know if you can call that the marginal demand function or not, but D prime of X over D. I think that was it. I'm gonna glance I like to try to test my memory and exercise it. Like the more I push it, the better it gets, is what I'm noticing. And it looks good, okay? So now, let's see what else do we have. Let's see, the demand function, okay, so let's write that down. So it says that Q, which is our D of X, is given by 120 minus 2X. Okay, so let's find the elasticity of the demand. So part A. So then part A, so the elasticity of demand is going to be negative times X. The derivative here is just going to be negative 2, right? So D prime is just negative 2 over D of X, which is 120 minus 2X, right? That should be it. Because we just wanted the function, and we have it now. Okay, I'm going to go with this for part A. I'm going to submit this. Okay. And, oh no, come on. Like this, style, like this, and I want to copy that. Okay, so I'm going to go with that for part A, and we'll check it momentarily. For part B, we're asked to find the elasticity of demand when x is 2 and 5 and interpret the meanings, right? Now, remember when we introduced elasticity of demand, we had some context. We had a theorem number 11. So we want to consider the elasticity when x is 2 and when x is 5, right? So the elasticity of demand when x is 2 is going to be -2 times -2 over 120 minus 2 times 2. I just plugged in 2 for x, right? On top, we get 4. On bottom, 120 minus 4, what is that, 116? Yeah, these should both be divisible by 4. There's going to be a 1 on top. There's what, 2 there, remainder of 36, which is 9, 29. Okay. So notice that this is less than 1. So notice that the elasticity of demand when x is 2, we got 1 over 29, which is less than 1, right? So if we look at theorem 11 says that the revenue should be increasing. So total revenue, so this implies that the total revenue is increasing. Okay. Okay. So then let's find the elasticity of demand when x is 5. It's going to be negative, oh, where's my formula? Sorry, it's going to be negative, what, 5? So negative 5 times negative 2 over 120 minus, I think it's 2 times 5. Okay. On top, we get 10. This is like irking me. This has to be on the same line. There you go, that's better. On top, we get 10. On bottom, 120 minus 10 is 110. We can knock off the trailing zeros, and we get 1 over 11. Okay, I was kind of anticipating something larger than 1, but I guess this makes sense. So we got the same thing for both. Total revenue is increasing because they're both less than 1, right? Okay. So I'm going to let that be. We got the same result. They both were less than 1, so that implies that the total revenue is increasing. Okay. So we finished part B. Find the value for which the elasticity of demand equals 1. And then what's the significance of this price? Okay, let's put C. So we want to solve the equation, when is the elasticity of demand equal to 1? So then we're going to have, on top is basically going to be 2x. On bottom, we're going to have 120 minus 2x under 2x. I think that's okay. We want to solve when that's equal to 1, right? Okay, I'm tempted to multiply both sides by the denominator. I feel like that might be a little bit easier. Instead of multiplying both sides by the denominator, I'm going to set it to 0. I'm going to do the 120, because sometimes when you multiply like that, it you kind of miss stuff. So I'm doing it the way I think is a little bit more thorough. Okay, so then a common denominator. So this is going to be the same as 2x minus 120 plus 2x over 120 minus 2x, all right? So if you get a common denominator, both the top and the bottom are the 120 minus 2x. You distribute the negative, you get something like this, equal to 0. We combine like terms. On top, we're going to have 4x minus 120. On bottom, we're going to have 120 minus 2x equals 0. And again, this fraction is only going to be 0 when the numerator is going to be 0, right? We could find an x that makes the denominator 0, but that's going to make the thing undefined. So we really only need to set the numerator equal to 0. So I guess I do need another page. Going into my third page of handwritten notes. If we set the numerator to 0 and solve, 4x minus 120 equals 0. Add and divide, x equals, what, 30? What's the X? X is, what was the X? X dollars per day. So it's basically saying is the revenue is going to be maximized when we sell the games for $30 per day. Did we have an example where we sold something more than 30? Okay. So X equals 30 implies that the revenue is maximized when we sell the games for $30 per day. Okay. Let me I kind of want to shrink all this down. I just wanted to fit on one page. So what I'm going to do, I think is, let's go here. I can focus on this. Yeah, I just wanted C to fit on one page because we didn't really need another page. Okay. We get rid of this. And I think we are ready to jump back into it. We're going to go view and we're going to go back to single page. Okay. So let's see, how do we do? Okay, so to find the elasticity of demand, first we find, 20. See, I knew something felt a little off. Yeah, this thing keeps missing like numbers. Or maybe, okay, that was on me this time. Somehow I wrote 2 instead of 20. I was like, these numbers, that wasn't interesting. Okay, so we wrote the original problem down wrong. Let's go back and redo it and adjust for that mistake, right? So here, that should have been 20. Let me get it to pop using, I'll use this color. That was supposed to be 20x, right? Okay. So then x, when x was 2, so, okay, so the elasticity of demand here, the derivative now becomes negative 20, so this becomes, instead of a 2, that's a 20, okay? And then we have an adjustment here as well. This is 20x, okay? So that should be okay. Then when x is 2 and 5, okay, so we need to go back and redo all of these. Oh. So I'm gonna get rid of this and start from, we can start from there. Yeah, because I was like, that wasn't interesting. I was like, those results, I was like, that wasn't driving any point. X is 2. Okay, we got our negative. So instead of that being a 2, that's 20x. This should have been a 20. And we also need a 20 here. Okay. So then now with these adjustments on top, we get what? 40. On bottom, 120 minus 40 is 80. So on top, I think we said we got 40. On bottom, we got 80. So then this was equal to a positive 1/2. And again, so that's less than 1. So that means, so that one implies, this implies total revenue is increasing. Okay, so that ate up a lot of our time, but that's okay. And then the second part, now we repeat this, but let x be 5. So what I'm going to do is copy this, hop over here. We need to at least get rid of this. Actually, we need to get rid of all of this because we had the wrong formula. Delete. Okay. I think we should be good with this. Okay. So then part B, now we're looking for the elasticity of demand when x is 5. And let me paste. Let me just erase this. Move this into place. And this is supposed to be 5. So this is a 5. I think this is a 5 and that's a 5. 5 and 5. I think that's correct. Okay. So then on top, 5 times 2, so that's 100. On bottom, 120 minus 100 is what, 20. Notice that's what I was anticipating. 100 divided by 20 is what, 5. Notice that is bigger than 1. So that implies the total revenue is what? Decreasing. Okay. So then for part C, we wanted to see what value of x is the elasticity of demand equal to 1. So then we're going to have, basically on top, it's going to be 20x. And I guess I can make that adjustment here as well. I mean, it's not that difficult to make that adjustment. On bottom, we have the 120 minus 20x. Okay. We want to see when is this equal to 1. So then I like the setting to 0 technique, 120 minus 20x, 20x, basically minus 1, so it's going to be minus 120 plus 20x equal to 0. And again, a fraction is only going to be 0 when the numerator is 0. All right, so we're going to ignore the denominator for right now. What is that? 40x. So 40x minus 120. So then we have 40x minus 120 equals 0. X equals 3. That makes more sense. I was like, these numbers are weird. Like, they gave us an example where they were selling the games for $2 and $5, and then we said it's maximized at $30. I was like, that's a huge jump. We found the mistake. This is more reasonable, right? So it's maximized, and that makes more sense because, like, okay, if we sell it for $2, the total revenue is increasing. If we sell it for $5, the total revenue is decreasing. So then it makes sense that, you know, we get to maximize the profit. It falls somewhere between those two results, all right? We sell it for $3 a day, like that. That makes more sense. Feel much better now. Okay, so let's go back. Let's change our view back. Yeah, I was like, why are these numbers coming out so weird? Anyway, we got to the bottom of it. We dx. Are they factored out to 20? Yeah, that's fine. Yeah, that's okay. So we got to have for part B for elasticity when x is 2. Small percentage increase in price will cause an even smaller decrease in the quantity of demand. Since the demand is inelastic, by a small amount will increase the total revenue. Okay. And then when it's 5, the elasticity is greater than 1. Thus, a small percentage increase in price will cause a larger percentage decrease in the quantity demanded. Oh, so this gives us the play between supply and price we're selling it and the demand, right? Like if you increase, you know, as you increase the price, the demand goes down. As you decrease the price, the demand goes up. So then this gives us a sense of what's the sweet spot between price versus demand. That's really interesting. And then for part E, well, when is it maximized? It says it's maximized when the elasticity is equal to 1, and we got sell it for a price of $3 per day, or sell it for 3. At $3 per rental, Click's video game will maximize the total revenue. The demand is this, rentals per day, and the revenue is this. So 60 rentals per day, and it'll generate a total revenue of $180 per day. That was pretty interesting. Let me check my time. We're actually doing really good on time. Okay. Because of that, we missed that 0 that did eat up a lot of our valuable time, but that's okay. I usually leave the quick checks for you all, so I'm gonna do that here. You definitely want to give those a go and make sure that you're getting these concepts. And I think this is actually the last example for this section. So there's another example on elasticity of demand. It's example 2. It says, this is business elasticity of demand. It says Wayne's Honey Farm sells honey-based moisturizing cream for $12 per jar. At this price, it sells 14,500 jars a month. To see if the price is too high or too low, Wayne's Honey Farm raises the price to $18 per jar. At this price, it sells 10,750 jars per month. Use the exponential demand function this to find the elasticity of demand and the price at which it should sell its jars of moisturizing for demand to have unit elasticity. Also give the resulting total monthly rental. Okay, basically it's a repeat of what we just did with just a different scenario. Okay, so let me add a page. This one, I think I'm going to screenshot the demand function and just load it onto the blank page. Delete that one. We want to copy from here. I guess we can get this too, because these are the instructions. You know what? We might need. I think I'm going to take a copy of all of this. Let's go like that. We're going to drop it right here. So we have everything nearby ready to go. Okay. So first we're asked to find the elasticity of demand. So I think earlier again, we said the elasticity of demand is going to be negative x times d prime of x over d of x, right? So in this case, our d of x here, our demand function, so our q, which is our demand function, it looks like it's 26,380.746 e to the negative 0.04987x. Ugh. Totally ran out of space. I'm going to go with it for now. Okay. So then d prime, we want the derivative. Remember for the exponential function, it's its own derivative, so we need to rewrite it. 26,380.746 e to the negative 0.04987x. Then we got to say times the derivative of the exponent. The derivative of the exponent is just that number, so we're going to say times is negative 0.04987. Okay. I mean, we could simplify it, but I'm just going to leave it like that for now, for the sake of simplicity and time. Nope, undo. And I want this guy. I'll shrink this down so it can fit better. Okay. I guess I might as well do that on the other row as well, where I know we ran out of space. Okay. Let me add a page. Let's change the view to seamless. Okay, I didn't crunch the number. We probably should, but I'm not going to. I'm going to let that be. So that's part A. And then part B, find the price at which it should sell its jars of moisturizing for demand to have a unit elasticity. So basically, we want to maximize the total revenue. Also give the resulting total. Okay, that's fine. So yeah, so basically set it equal to 1 and solve. And let's start on the next page. Okay. Let's see. I probably should crunch that number. Okay, I'm going to use Siri. Hey Siri, what's 26,380.746 times 0.04987? Yeah, I knew my hesitation was going to throw it off. I tried to get it out. Oh, I think she got it. Okay. 60, 60, 78, and there's a negative we need to account for there. We have our E. That's what, wait a minute. Oh, that's not the final thing. Yeah, we got to go back. I'm totally like moving too fast. Let's get rid of this. We're gonna come back to that. That's not the elasticity of demand. That's just D prime, right? They didn't want D prime. They wanted the elasticity. So then our E of X, we need to say X times that. Man, I don't feel like writing any of that. I think you get it though. I'm not gonna write it just for the sake of time and just because I'm being a little bit lazy. But I'm just gonna say basically apply the formula. Okay, apply the formula. Not formula, formula. Okay, I'm just being lazy right now. Okay, so then part B, we want to maximize the total revenue. So let's do this. We need the elasticity, we need the E of X, we need that equal to 1. So we're going to say negative X d prime, I think I'm gonna just copy and paste this. So if we copy, and again, we still haven't simplified, but that's okay. We're gonna say negative x times this divided by the original. So all of that over the original, I'm just gonna copy and paste that as well. Copy, paste. So we said negative x times d prime over d. We need that to equal 1 and solve. Okay. So then we can honestly do what we did last time. Let's see. I need to crunch some of these numbers. We do have some cancellation going on. Let me think about it. Because it looks like we could cancel all of that. Because those are repeats. So if we have a repeat at the top minus 1, what happens if we simplify it first? I'm going to simplify it first and see what happens. All right, so what I'm seeing is, looks like this. Here, let's do it like this. Like this guy can cancel this guy. It looks like it. I'm going to try it. If it don't work, we'll fix it. Style. So the blue on top cancels the blue on bottom. Looks like this. I'm just going to do that just to see what happens. It looks like we can do it. So then what we're left with, can we do this? I think I'm jumping the gun. Let me keep going. I just want to see what happens. So double negative, we get this 0.04987 times x minus 1 equals 0. I don't know. If it don't work, we'll go back. We'll do the harder thing that I'm trying to avoid. Ultimately, if we add and divide, x equals 1 over this 0.04987. Hey Siri, what's 1 divided by 0.04987? 0.521, and that's an approximation. What does this mean in the context? Let me see if this is reasonable. Find the price, should sell as jars of moisturizing cream. That makes sense. You can buy moisturizing cream for $20 to have a unit elasticity. Also, give the resulting total monthly revenue. So what's going to be our total, the demand? Okay. So then it says at this price, it sells. How did we do it last time? Let me see something. I'm just going to check something real quick. Not the quick check right here. So this price is resulting $3 will maximize. The demand is going to be 60 rentals per day. So the revenue is 3 times 60. So then we can find the demand. Okay, so then if we sell these for about $20, if we sell it at that price, the demand, we can get the demand. So we plug 20 into that function. I would need a calculator. I'm just being lazy about opening mine. But if we sell it at about $20 and 5 or 6 cents, if we sell it at that price and plug that price into the demand function, that'll tell us the demand. So then the total revenue is going to be that price times the demand. I'm just going to use the notes from here on out because I just don't want to open the calculator. I'm just being totally lazy. But I think it's not difficult from there. Okay, I think you can handle it. That's the only reason I'm doing that. Okay, so let me do like this. And let's kind of compare to what was the notes, the prepared notes are saying. Let me see the time. Okay. And then I'm kind of like pressed for time a little bit too. Okay, so to find the elasticity of demand, negative x times d prime over d. Okay, we had a cancellation. Yeah, I think we got that. Elasticity of demand, 4987 times x. Yeah, right here, because we cancel it. You see it there, right? So you see it right there. Okay, so we got the same result. So I'm gonna let that be. Then To find the price at which it's gonna it should sell the jars. Basically, the elasticity of demand needs to be equal to 1. You set it equal to 1. You see the 20.05. We got the same result. So therefore, Wayne's Honey Farm should sell the jars for $20.05 per jar. This would maximize the revenue. The monthly revenue generated would be the 20.05 times, you basically plug the 20.05 into the demand function, and you get, man, almost $200,000 a month. Pretty good. That was fun. I like that kind of stuff, right? So we have this summary, the section summary. I don't think I have time to go ahead and do the next one, so we'll save that for another time. Um, so for a demand function, the elasticity of demand is going to be given up by this guy, negative x times d prime over d. The demand is inelastic when the elasticity of demand is less than 1. If the demand is inelastic, then with a small increase in price, the revenue increases. Right? The demand is elastic when E of x is larger than 1. If the demand is elastic, then with a small increase in price, the revenue decreases. That's interesting. So demand has a unit elasticity when the elasticity of demand equals 1. If the demand has a unit elasticity at price x, then revenue is maximized. So this is kind of giving us a sense of the play between price versus demand. You know, as the price goes up, demand goes down, vice versa. That whole spiel that we gave earlier. And I think that closes it out. That was an adventure. Hopefully you had some fun and learned something, and we were able to grow together. On that note, we're going to end the session here, and from one beautiful mind to another, enjoy the rest of your day. Peace.